Morning everyone, my name is Danilo Giordano and this is the video for my PhD Prize Award 2017. First of all, let me briefly introduce myself. I started my PhD in 2014 under the supervision of Professor Marco Mellia. During this year, I had the opportunity to cooperate either with industry, such as Narus, a company with headquarters in California, where I also spent 2 months during my first year. This partnership gave me 2 papers. One of them finished in a patent and also won the best paper at the ITC conference. Secondly, I had the opportunity to work with another research center called CADA during a research center located in UC San Diego University, where I spent 6 months during my last year. This cooperation gave me 1 paper that also won the prestigious Best Paper Award by the Internet Engineering Task Force. In order to continue my research activity, I submitted a project to the Siebel Institute of Energy, project related to the evolution of car sharing system in Italy. This project won the grant, so I can continue my research for an extra year. During my PhD, however, my focus was on monitoring the internet infrastructure. To do so, I divided the problem in 3 main parts. First of all, clients monitoring. So I monitor the clients that are all of us that access the internet asking for content such as YouTube videos or asking for services such as the Google engine. In order to do so, we send our traffic toward the internet infrastructure, which is an infrastructure composed by 100,000 of nodes, and send our traffic from us to the servers that serve our contents. Serve our request by sending us back the content we are looking for instance in case of YouTube servers or La Stampa News, or give us the service we are looking for. To perform all this monitoring analysis, I had to face 2 main problems. The first one is the data acquisition problem. The second one is which methodologies to use to analyze the acquired data. For the first part, I rely on dataset available here at Politecnico or on the other research center, so my main contribution was on the second part. As the methodology, I use methodology from 3 main families. The first one is from the mathematical and statistical family that I use first of all to characterize the data and then, for instance, find statistical correlation over time. For instance, on the client study, I used mathematical tool to create a client fingerprint based on which website they visit. And secondly, I use statistical tool to try to identify the user among many others. Secondly, I use machine learning solution. I use this solution to model the data in order, for instance, to reduce the complexity, as I will show you on the server study. Finally, I used also big data frameworks that allowed me to characterize very large dataset that I was not able to analyze with a single computer in a feasible time. For instance, when I had to analyze the internet infrastructure to study its growth or find for malicious activities. For the server study, I decided to study the YouTube servers. I decided to do so because it has a very massive infrastructure composed by thousands of servers that manage about 20% of worldwide traffic. Unfortunately, sometimes these servers do not work well, and so there arise anomalies that sometimes have an impact on the client's quality of experience, that have problem watching YouTube videos, or sometimes they are not even able to watch YouTube videos at all. So what they do is they go to complain to their ISP, and so the ISP would like to have a tool able to identify this kind of anomaly before the user does, and being able to suggest how to react. To do so, I designed a methodology that, starting from a dataset available at Politecnico, that for a group of clients gives me which video they wanted to download from YouTube, they give me how long time they took to download the video, and many more information. Does the following. First, group the YouTube server in few groups in order to reduce the complexity of the problem by using the dbScan unsupervised clustering algorithm. Secondly, by using the novel notion called pattern similarity, study the evolution of these few groups over time, so from one snapshot to another. Then, by evaluating the pattern similarity trend over time, I'm able to spot changes. Some of them are also anomaly. For instance, the one depicted here is an anomaly in March 2014, where a group of caches servers named Brett Frankfurt had a throughput lower than 500 kilobits per second most of the time, while the other 2 groups of servers, namely Milan and Good Frankfurt, had a throughput very well greater than 1000 kilobits per second most of the time. So in this case, this tool had been able to highlight the anomaly. So to conclude, monitoring is a very fundamental task to understand the network, keep our information updated. Unfortunately, there isn't a single monitoring solution for all the case, and so each monitoring solution asks for a specific methodology. Big Data Framework is one of them, which is nowadays a fundamental solution to cope with the growth of data. Thanks for your attention.